Hello guys, and welcome to the first tutorial of Statistics 124. So my name is Benny, and I've been tutoring this module for the past 5 years. All right. So this is a tutorial specially designed for statistics student, first year student in the Northwest University. However, if the content is similar to other institutions, you guys can find this useful as well. Okay, so today we're doing study unit 1, which is correlation and linear regression. All right, so we'll be doing the one for bivariate data in this one, and we'll be focusing only on part 1. So there will be part 2, which is going to be multiple regression. This is just going to be simple correlation and linear regression. All right, so these are the things that we need to know. Introduction to correlation and linear regression. We need to know how to draw a scatter plot, interpret relationships using correlation coefficient and scatter plot. And scatter plot. You need to know causality. You need to know how to calculate the least squares regression equation. You need to know how to determine a dependent variable given an independent variable. You need to understand interpolation and extrapolation. You need to know how to calculate and interpret coefficient of determination, and then you also need to calculate residuals, interpret and represent them graphically. Alright, so let me just do this. Uh, Create a dependent variable, not an independent variable. All right. So now, for the introduction, before we get to everything, we need to introduce and understand what correlation and linear regression is. So basically, this is just the relationship between two variables. In most cases, it's going to be the x and the y variable, or in always the case, it's going to be x variable and y variable. So we want to know how are they related. How does one uh, affect the other? Okay, in most cases is the x variable that is the independent, so it affects the y variable, which is the dependent. Y depends on the x, right? All right, so we're gonna understand this when we go in depth and get to do the examples like this one over here. Okay, so but before we get there, I want to also explain correlation. So regression is more like the relationship between x and y, and then correlation basically tells us the effect of that in a way that, okay, if we say there is a positive correlation, for example, we basically saying that if one variable increases, the other also increases. That is a positive correlation. And a negative correlation basically means that if one increases, the other decreases. So we will see that when we get to the part of the scatter plot, and yeah, when you get to the part of the scatter plot and how to identify which one is positive, which one is negative, and then we'll also get to identify which one is weak and which one is strong. Okay, so now uh, that is the introduction about correlation and linear regression in simple terms. So we need to know how to draw a scatter plot. Ne? All right. So I don't think they will ask you to draw a scatter plot, but if they do, then you should know how to do it, right? Okay. So uh, remember, stats 124 is going to be open book, or at least it was for the past years. I'm not sure about that. Maybe they changed the syllabus or the content, something like that. But it's not going to be a multiple choice just like STTN121. It's going to be open book, but that doesn't make it any easier. You need to practice for this module. All right. So how to draw a scatter plot. That is the second thing that we're going to do. So this one we're done with it. So now we need to know how to draw a scatter plot. So we're going to use this information here, and I'm going to show you guys how you draw this scatter plot, right? So it's going to be a rough sketch, but you must know that you must draw it according to scale in the exam or in the test. Okay, so let's use this information that we have here. A sneaker reseller wants to know if the number of Instagram promotional posts per week affects the number of sneakers sold that week. So okay, so now we have two variables. The variable which is X, which is the number of promotional Instagram posts, and we also have the number of sneakers sold that week, which is the Y variable. So we want to know if posting a lot of IG pictures about the sneaker will increase the number of sneakers sold that week. Ne? Alright, so we can see that week one there was only one post, and that post resulted in 5 sneakers sold. Week two there was 3 posts, resulted in 9. Two the following week resulted in 6, and so on and so on. And then we can see that other weeks, like week 7, there was no post and there were only 3, right? So basically we can see that the more the number of sneakers, the number of posts increased, the number of sneakers sold for that particular week also increases. So we can say that before doing anything, we can clearly see that we have a positive correlation or a positive relationship between IG posts and the sneakers sold for that particular week. So now drawing a scatter plot with this, it's as simple as it goes. So basically, we don't focus on the weeks. This is just to show you the number, the sample size. In this case, it's 10 weeks. So we're going to focus on only the X and the Y variables here and here, right? So to do this, I'm just going to shift this up a little bit. Yeah, I just need this table over here. Right, so I'm just gonna do a rough sketch of the scatter plot, and it's gonna look something like this. It's gonna look something like this, and then this is going to be our let me just shift it down a little bit more. So we're going to have here, let me just type, this is the X variable, which is the IG posts per week. And then over here I'm going to have our number of sneakers sold, which is the Y variable. Number of sneakers sold. I'm just gonna rotate that and put it over here. Right, so this is the number of sneakers sold, and this is the IG post per week, right? Okay, so now we need to do some plotting of the points. Ne? We need to do some plotting of the points. Alright, so I'm going to write uh, I'm gonna write okay, I'm going to write number of posts. I see the lowest is 0 and the highest is 6, so I'm just gonna write 1 up to 6 over here. I'm just gonna write 1, 2, 3, 4, 4, 5, and 6. So remember, you need to draw this according to scale. So now this is just an example to show you how basically this is going to look like. All right, so yeah, something like that. We have 1 up to 6. This is the number of IG posts per week, because I see 0 is the lowest and 6 is the highest over there. So 0 is going to be here, ne? 0 is going to be here, it's the origin. And then the number of sneakers sold, I see that we have from 3 being the lowest and 15 being the highest. So for this, I'm going to use a scale of 2. I'm going to use the scale of 2, so I'm going to say 2, 4, 6, 8, 10, 12, 14, 16. Yeah. Alright, so let me just do the spaces in between them. Okay, basically let me do it like this. Let me let me start here actually. Let me start here. Let me start with 16, then enter. Let me just move it here. Okay, 16, and I'm gonna say 14, 12, 10, 8, 6, 4, and 2. Okay, 2, 4, 6, 8, 10, 12, 14, 16. Cool. So now these are our points. These are our values, I mean. So now we're gonna plot this using this information. Or we're gonna plot this information on this. So that is the scatter plot. All right. So now the first one, we see that on week 1 there was 1 post and there were 5 sneakers. So when x is equals to 1, our y was equal to, I'm going to use, let me use a green one for the points. Okay, so if x is 1, y is equals to 5. So 5 is somewhere between 4 and 6, somewhere there. So I'm going to put a point there. So that is the first point of our scatter plot. And then the second one is 3. So 3 here, and x is 9. 9 is between 8 and 10, somewhere there. And then followed by 2 and 6. So if x is 2, y is equals to 6, right there. 2 and 6. And then if x is 5, y is 13. If x is 5, y is 13. 13 is somewhere between 12 and 14. I'm going to place it right there, just above 12, between 12 and 14. And 5 is here, so I'm going to put it there. And then followed by 4 and 11. 4 is here, 11 is between 10 and 12, so I'm going to put it there. And then 4 and 11, then 6 and 15. So 6 and 15, 6 is here, 15 is going to be somewhere between 14 and 15, is over there. Followed by 0 and 3. So 0 is here, 0 is here on the line, and then y is going to be equals to 3, which is between 2 and 4, is going to be there on that line. And then 2 and 7, 2 is here, 7 is going to be somewhere between 6 and 8, so it's going to be there, yeah. And then 3 and 10, 3 is here, 10 is just above this. And then last but not least is 5 and 14. 5 and 14 is over here, just above this one here. So that is our scatter plot. So how many points we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points, 10 weeks. That is our sample size. So that is how you actually draw a scatter plot. Simple. So you can actually see from a scatter plot if there's a positive relationship or a negative relationship. And I'm going to show when we get to, when I explain the scatter plot after this. So this is how you actually draw a scatter plot as per one of our uh, as per one of our study outcomes. So I'm just going to tick that out over there. That is how you draw it. That's how you draw a scatter plot. So basically just check your x and your y, and then you just draw this according to scale and put it here, right? Simple as that. Okay, so now we're going to go to interpret relationship using correlation coefficient and scatter plot, ne? Okay, so before we get to the scatter plot, I want to address the part of the correlation coefficient, ne? All right, first of all, you need to know how to calculate that. So they might ask you to calculate the correlation coefficient given given this information. So the correlation coefficient is denoted by small letter r. So that is the correlation coefficient is denoted by small letter r. So they might give it to you and say interpret it, or they might ask you to calculate it. So how do we calculate it? So given this information here, the simple way to calculate this is to use the calculator. The simple way to do this is to use the calculator. If you just use the calculator, you calculate the value of R and write it. If it's 2 marks, 3 marks, or 4 marks, they'll give you full marks. You just say R is equals to this. So how do we calculate it? Alright, so now I'm going to show you guys how to use the calculator to calculate this. First things first, let me just open my calculator. So you're going to press mode. After pressing mode, the calculator is going to tell you, okay, sharp, I'm in my mode right now. What module are you doing? You tell it, I'm doing stats. You see, you talk to your calculator, I'm doing stats. Okay, cool. So now you're doing stats, right? This is the information I have on stats. Which part are you doing? Ne? Right. So if you can remember from stats 111 as well, linear correlation and linear regression and correlation is a plus bx, which is option 2. So you're gonna give option 2 here. So it's gonna ask you for your x and your y values. So you go and give it your x values and y values. Remember to press equal after each and every value. We're gonna start with the ig post 1, and then you press equal, and then you're gonna press 3, then press equal, 2, press equal, 5, equal, 4, equal, 6, equal, 0, equal, 2, equal, 3, equal, 5, equal. So you can see that I have up to 10 values on the calculator. Here you can see 10 is 2. So meaning that so far my information is correct. You need to verify that information is correct, because the calculator will give you a wrong answer if the information is not correct. And then you have to make sure that they correspond. 1 corresponds with 5, 3 corresponds with 9, 2 corresponds with 6, and so on. 13, 11, 15, 3, 7, 10, and 14. As you can see, the last one is 5 and 14. They do correspond. After this, you tell the calculator I'm done by pressing AC. You give it some time to cool down. AC for air conditioning. So it cools down, but the information is still there. So you're going to press shift. You shift it now to the answer mode. Shift, and then you press stat. Because if you can look at stat here, 1 here, there is stat on top here. So you're going to press 1, and then it's going to say, okay, this is the information and the answers that I have. And then you go and say, I'm looking for regression, because we are doing what? Regression, linear regression, and correlation. So you're going to press 7. But in your calculations, I think it's going to be 5. So this is a electronic calculator, that's why it's 7. In most calculators scientific, it's option 5. You're going to choose that option 5 for regression. So we're looking for small letter r, that is option number 3. So you're going to press that and say equal. Ne? So it says 0.99. Ne? So if they say round it off to 2 decimal places, it's going to be 0.99, as it is 0.99. Please do not round this off. Do not round it off to 1. Ne? The reason for this is, this shows that it is a very strong uh, positive uh, linear relationship between x and y. And why am I saying this is, if you can look at this line, it's going up. Ne? It's going up. So basically, how do you know that the relationship is positive? By looking at the graph. You look at the graph from the left. So if that graph is going up, then it's positive. And then if the points are closer to each other, then it's strong. So meaning that this is an example of a strong positive linear relationship between x and y variable. Ne? Right. So the reason why I'm saying do not round it off to 1 is because if you round it off to 1, it means it's a perfect linear relationship. A perfect linear relationship basically means that all the points are on a straight line. And you can see that if you can draw a line here, some points will be closer to that line, but won't be exactly on that line. So basically, that is why we cannot round it off to 1. Ne? I'm going to explain that by giving you the properties of the correlation coefficient, which is this part here that we're busy with, interpreting relationship using correlation coefficient and a scatter plot. So for now, we're going to go to different types of scatter plots, and then we're going to come back to the correlation coefficient. I just wanted to show you guys how to calculate it using the calculator. Right. So now these are the types of scatter plots that we have over here. These are the types of scatter plots that we have. Let me just zoom this one out so that you guys can see, and then this one over here as well. All right. So now I said that how do you see that you have a positive or a negative relationship? You look at the graph from the left. Always look at the graph from the left. All right. So we're gonna start with this one. Looking at this graph from the left, or looking at this point from the left, we can see that they are going up. They are going up. So basically means that this is positive. They're going up, so it is positive. And then now the second thing that you look at is are they close to each other or are they far from each other? Are they scattered or are they close to each other? We can see that these points are close to each other. So meaning that if they are close, then they are strong. So meaning this, we can say it is a strong, it's a strong positive relationship. Relationship, or you can say linear relationship. So there's a strong positive linear relationship between x and y variable. Let's look at this one. Looking at this from the left, it goes down. Looking at this from the left, it goes down. So meaning that it is negative. From the left going down is negative, from the left going up is positive. So it is negative, but the points are still closer to each other. So we can say that it is strong, but it is negative. So it's going to be strong negative linear relationship. Relationship is a strong negative linear relationship between x and y, right? But then one thing I just want to clarify now before I forget. In the test, they will give you the name of the x variable and the name of the y variable. Like in our example, the x variable was the ID post and the y variable was the number of sneakers sold that week. So I don't want you to say, if they say interpret the correlation and you say there is a strong positive relationship between x and y, you must be specific. In statistics, we are specific. So you're going to say there is a strong positive linear relationship between the ID post and the number of sneakers sold that week. You must be specific like that, right? Okay, so but then now, because this is just general, that's why I'm just saying a strong positive linear relationship between x and y, because it is not mentioned which one is x and which one is y. So this one is a strong negative linear relationship. And then the next one is going to be, looking at the graph from the left to the right, it's increasing, because you can see the small one is here. The first one is here and the last one is over there. So it's increasing as it goes to the right. Né? It goes up. So it's increasing, that means it is positive. But if you can look at this point, they are scattered compared to this one. So it is positive, but it is a weak positive relationship. So we're going to say weak positive relationship. It's a weak positive relationship between x and y variable. Looking at this one now, it's going down from the left, and it's also scattered. So it's a weak negative linear relationship. This one is going to be a weak negative relationship. It's a weak negative relationship. And then now this one. So as you look at this one, it goes up, and then all of a sudden it goes down. So it doesn't go up, it doesn't go down. So in this case, you can't say there's a linear relationship. There might be some other kind of a relationship, but just not a linear relationship. So in this case, you're going to say there is no linear relationship between x and y, because you can't say if it's going up or it's going down, because it's going up and down. Understand? So for this one, you're going to say there is no linear relationship between x and y variable. There's no linear relationship between x and y variable. And that is how you can tell the relationship or correlation using a scatter plot, right? Okay, and now for the correlation coefficient. So I already showed you how to calculate the correlation coefficient here using the calculator. And now for the properties, né? For the properties, because you should use both uh, the scatter plot and the correlation coefficient. And for this, I'm just going to draw a small uh, diagram for you, just a small drawing to understand or to summarize the uh, to summarize to summarize this properties of the correlation coefficient. And I'm going to say -1 here, I'm going to say +1 here, then I'm going to say 0 here, I'm going to say minus 0.5 here. So this is just something that I came up with just to make it easier for my students. 0.5 over here. All right. So now from here, I'm going to do this. I'm going to do this. All right. And then I'm going to do this one as well. I'm going to do this one as well. Uh, I'm going to do this one over here and this one over here. And then I'm just going to write some few things. Here I'm going to write negative, negative, and then here I'm going to write positive. Here I'm going to write weak. Control C, Control V. I'm going to write weak over here, weak, and then I'm going to write strong. Oh, sorry. I'm going to write strong, and I'm going to put this one here, and I'm going to put this one here. Okay. So now, basically, this is the properties of the correlation coefficient, which is known as the small letter r. So these are the properties. So in simple terms, the correlation coefficient ranges between -1 and +1. Ne? So let me just say perfect here. Let me just write the word perfect here. Uh, perfect. And perfect. Yeah, so these are the properties of the small letter r, which is the correlation coefficient. Sometimes it's also known as the Pearson's correlation coefficient. Ne? All right, so now basically what I'm saying here is if it is above 1, from 0, above 0, sorry, from 0 to 1 is positive. Ne? Is positive, and you can actually see that with like the sign, if it's a positive sign or a negative sign. Ne? All right. So from 0 to 1 is positive, and from 0 to -1 is negative. We all know that, right? So now I just wrote these numbers minus 0.5 and positive 0.5 to differentiate between the strong and the weak part of this if you're given the correlation coefficient. Nah. So now if the number is positive and it's more than 0.5, then it's strong. And then if it's less than 0.5, it's weak. If the number is negative and is less than 0.5, it's weak. If it's more than 0, if it's less than 0.5, it's strong. If it's more than 0.5, it's weak. Okay? All right. So some examples. Let me just give an example here and say r is equals to 0.68. Ne? So the first thing you're gonna ask yourself um, is this positive or negative? Then it's positive. You can see there's no negative sign here. It's positive. And then you're going to ask yourself, is it more than 0.5 or less? It's more than 0.5. So meaning this is an example of a strong positive linear relationship. If you were to graphically represent this, it would be this one over here. It's a strong positive linear relationship. This is positive, there's no negative sign, and it's more than 0.5, so it is strong. So it's a strong positive linear relationship. Let's get another example. Minus r is equals to minus 0.34. Ne? First things first, you ask yourself, is this positive or negative? It's negative because it is a negative number. It's a minus. Minus 0.34. So 0.34, is it more or less than 0.5? It is less. So meaning that it is weak. So it's going to be a weak negative linear relationship. An example of that would be this scatter plot over here. So that is how you interpret the correlation the relationship between two variables using the correlation coefficient and the scatter plot. I think this makes some sense. Another example, r is equals to 0.9904. Let's give this for example. So I said to you guys, do not round this off. It's 0.9. It's positive and it is very strong because it is closer to 1. It's not exactly 1, so don't round it off to 1. It is closer to 1. So it is strong, positive, linear relationship. Just like this one over here that we had for the IG post and the number of sneakers sold. So that is what we say it is a strong, positive, linear relationship. If it is 1 exactly, then you're going to say it is a perfect, positive, linear relationship. If it is -1, it is a perfect negative linear relationship between x and y. Right, I think that makes some sense. So we're gonna move on to the next parts of our study outcomes. So I think this actually makes sense for now. All right. So now the next part is causality. So what does causality mean? Basically, causality is okay. Let's take this example that we have here: the IG post and the Nika sold. We want to know that we have established that there is a strong positive linear relationship between the IG post and the sneakers sold, right? So, but then we want to know that is it really the IG posts that are making the sneakers get sold a lot, right? So, not necessarily, not necessarily. And the reason for this is um, there may be a number of posts, but still at the end of the day, the sneakers are not sold that much. Let's take an example with 3, for example, here. There were only 3 uh, posts, but they sold 10 sneakers. So this means that there might be another variable that contributed to this. And to give an example, I might say that, let's say maybe the first sneaker was posted by someone who's working at that shop that is selling these sneakers, and then next week they made like 4 or 5 posts about that same person wearing those sneakers and stuff like that, and we don't know if that person is influential or that person only showed the post or the sneakers to some people that they know, and those people are those that went and bought those sneakers. But then let's say maybe on week 3 or week 4 or week 5, then the sneakers is posted by a well-known social media influencer. Then a number of people, a lot of people, even if it's like just one post, a lot of people can still come and buy that sneaker only because it was posted by someone very well known. So there are some other variables that can actually contribute to the number of sneakers being sold uh, that particular week. So the IG post, yes, can influence people to buy, but that's not entirely the reason why the sneakers would be sold. So that is actually what causality means. It actually asks if uh, the X variable 100% contributes to the Y variable. I mean, affect 100% affect the Y variable. Basically, meaning that if there won't be any posts for a certain week, there won't be any sneakers being sold. No, we can see that on week 7. There was no post at all, but 3 sneakers were sold. 3 pairs of sneakers were sold. So basically, it means that the IG post does not cause the sneakers to be to be sold. We can see that there by week 7. That's actually what causality means. Okay, in simple terms. All right. So now we have to know how to calculate the least squares regression equation. The least squares regression equation. Okay, so I'm going to use the same example for this one as well, and all the others remaining study outcomes. Okay, so determine or calculate the least squares regression equation. Ne? So the least squares regression equation is given by y cap is equals to a plus bx, a plus bx, in simple terms, né? A plus bx. So now, before you get to calculate it, we have to know what does a mean, what does b mean, because sometimes they can just ask you to calculate the value of a or the value of b, but without telling you a or b, né? So a is there, a is there, is the y-intercept, and b is the slope, né? So a is there, is the intercept, and b is the slope, né? A is the intercept and b is the slope. So sometimes they can just say, using this information here, calculate the slope of this graph, or calculate the slope of the least squares regression equation. So you have to know what does a mean and what does b mean, né? All right, so you can also calculate this by using a calculator. So let's say it's 3 marks and they say calculate the least squares regression equation. You can just say y equal a plus bx, and then the next thing you say the value of a is equal to, and then next you say the value of b is equal to, and then you write the information, the equation now in full. I'm just going to take this up here, and then now you write the information in full, yeah? All right, so the information is still in the calculator. You're going to follow the same steps of saying mode, and then you're going to press 2a plus bx, and then you're going to put the information in the calculator. So now, still, since the information is still in the calculator, after the information is there, you press AC, you're going to press shift, you're going to press 1, and then you're going to press regression again. On your calculator is going to be 5, like I said. So now you're looking for the value of a. That's the first thing. You're going to press 1, and then you're going to press equal. So that is 2.827, round off to 2 decimals. So I'm going to just write 2.827, 2.827. That is the value of a. And now for the value of b, we're going to press shift 1. The information is still there, 7, and then press 2 for b. That is equals to 2.088. It's going to be 2.088. Now you have this, and then you can just write y equal, let me just use this to type it, 2.827. Since well, this is the positive number, I'm going to say plus 2. This number here, 2.088. 2.088. So x at the end. Remember to put your x there. Right. So that is the least squares regression equation. Simple as that. Sometimes they'll give it to you and say calculate the independent variable given the calculate the dependent variable given the independent variable, which is the next thing to do. So in simple ways, this is how you calculate your least squares regression equation, right? So sometimes they'll give it to you in, using the STTN122, and you just have to write it. I'm going to show you guys in the next uh, 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 video what STTN122 basically is, right? Okay, so this is how you calculate it, having sample as simple as this, right? So we're gonna go to the next one, which says determine the dependent variable given the independent variable. All right, for example, we have this information here. Then you want to know how many sneakers we're going to sell if we post 7 posts for that particular week. You can see that there's no information of posting 7 IG posts and the number of sneakers sold if we do that. So that's what we want to determine now. So we're going to use the calculator for that. I'm just going to wipe out the information here because we have everything that we need. Right. So we want to know how many sneakers will be sold if we post 7 IG posts per week or on that particular week. Right. So now we're going to use this information. We're going to use this information. So you're going to say 2.827 plus 2.088 multiplied by, or you're going to say open bracket, and then you're going to put 7. So understand this. Let me just move this here. It says determine a dependent variable. What is a dependent variable? Is y. Determine y for a given x value, because given independent variable is your x value. So now we are determining y using this information for a given x value of 7 in this example. So basically we're just going to substitute everything in this calculator, and in this equation. We're going to substitute 7, and then we're going to get let the calculator give us the answer. So now the answer that we get there is 3.443. So since this is the number of sneakers, just like the number of people and stuff, you can't sell half a sneaker. So basically, for 7 posts, we expect no, this is not 0 point. I'm sorry for that. It's 2.008, and is, oh, it's actually 17.4. So you're gonna say, uh let me write it here so that you see that we substitute is equal to 2.827 plus 2.088 into 7, uh, into 7, and that is going to be equal to 14 point 14 point what 17 at 17.433, right? So basically, if you can look at the highest number of posts was 6, and there were 15 sneakers sold. So now with 7 posts we get what? 17.433, which is rounded off to be approximately, you're going to say approximately 18. So basically we're expecting to sell 18 sneakers if we post 18 pair of sneakers if we make 7 IG posts, right? So that is how you determine a dependent variable given an independent variable. So that is simply how you can do that. So basically we use the least squares regression to predict, to basically predict like how much we're going to sell given how much we post in this example. So we determine the value of y given the value of x. And that actually drives us onto the next part, which is understand interpolation and extrapolation. All right, so first things first, before you can determine or understand if this is interpolation or extrapolation, this is basically the simple way to do it. Allow me to erase this for now because I'm running out of space for this part. So just bear with me. I hope you guys uh, did that part. Okay, so um, before we get there, before we get to the interpolation and extrapolation, interpolation and extrapolation focuses on your x values, only your x values. Ne? All right. So the first thing that you're going to do is you're going to write your smallest x value, which is 0, your largest x value, which is 6 in this case, and then you're just gonna do something like this, and then you're gonna, yeah, you can do this as well. All right. So now this is interpolation, and then everything going that side is uh, extrapolation. Just gonna move it this side, and then I'm gonna copy and paste it to this side. Nah. All right. So for an example that we just did of calculating how many sneakers we will sell if we posted 7. So you're gonna ask yourself, is 7 between 0 and 6? If it is, then it's interpolation. If it's not, then it's extrapolation. But you can see that 7 is actually over 6. It's not between 0 and 6. So an example of uh, 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 an example that we just did is extrapolation. So if we're determining 7 IG posts, we're determining sneakers sold from 7 IG posts, that is extrapolation. Ne? So it's going to be extrapolation from here, from this side, because 6 is above 7. But in this example, extrapolation cannot uh, apply on the left side of this diagram here. Why? Because you can't have minus uh, any number that is less than 0, it's minus 1, minus 2, minus 3. So you can't have minus 1 number of posts. That doesn't make sense uh, in the real life context. So interpolation will be something like that. So if, let's say, for example, they say determine the number of sneakers sold uh, if we posted 2 IG posts. So that is 2 over here. You can see that was the answer was 6, or 2, the answer was 7. So you can actually use this to determine the estimated one, not the actual one, because these are the actual numbers. There's what we call the estimated one, which is here. We're gonna do that, especially when you come to the residuals, right? Alright. So uh, if we are determining the value of y using x equals to 2, 2 is between 0 and 6, so that would be an example of interpolation. So that is interpolation and extrapolation in simple terms. Moving on to the next one. Calculate and interpret coefficient of determination. Calculate and interpret the coefficient of determination. Alright, so the coefficient of determination is r squared. So basically, it's just taking the normal correlation coefficient, which is r, and you put it in brackets and then you square it. The reason why you put it in brackets is because the coefficient of determination is always positive. It's always going to be a positive number. So basically, unlike the correlation coefficient, it is not between minus 1 and positive 1. It's always between 0 and 1. It's always between 0 and 1. And how do we calculate that? Like I just said, we just take the correlation coefficient, like the one that we had here, which was 0.99. You put it in brackets and you square it. Then you get your coefficient of determination, 0.98 in this case. 0.98, is it 9801? 0.9801. All right, so it's from here. So don't be don't be puzzled. It's from here, as I showed you earlier on how to calculate it, right? So r squared is equal to 0.9801. So that is how you calculate it. It's always between 0 and 1. So this one doesn't tell you about the relationship. It tells you about the fitting of the least squares line to the data. Ne? So if it's closer to 1, you can say, let me just actually add 0.5 as well. Let me add 0.5 in the middle. 0.5. Ne? Alright, let me just add 0.5. And if it is more than 0.5, it feeds the data well. Ne? If it's more than 0.5, it feeds the data well. And if it's less than 0.5, it does not feed the data well. If it's exactly 1, it feeds the data perfect. And then if it's exactly 0, it does not feed the data at all. So it tells you about the fitting of the data. This tells you about the fitting of the data. If it is 1, it fits the data perfect. If it's more than 0.5, closer to 1, it fits the data well. If it is less than 0.5, it does not fit the data well. And if it's 0, it does not fit the data at all. So that is the how you calculate and how you interpret the coefficient of determination. Remember to put it in brackets. Let me just give you an example. If, for example, the correlation coefficient was minus 0.99 and you don't put it in brackets, you write it as like this, minus 0.99, you're going to get a negative number. And that is actually going to be wrong, because the correlation coefficient we just established is always between 0 and 1. It is never negative. So if it was like this, then that's what you should do. You should put it in brackets. You should put it in brackets. You should put it in the brackets. So if you put it in brackets minus 0.99 and you say equal, it's going to give you a positive number. So basically, it's always positive. You must put it in brackets and calculate it. That is how you calculate and interpret the coefficient of determination. And the last part of our study unit, part 1, is calculating residuals. Interpret the residuals and represent them graphically. Ne? Alright, so for this, I'm going to show you guys how to they won't ask you guys to represent the residuals graphically, or they won't ask you guys to, yeah, they won't ask you guys to represent them graphically basically, but they can ask you to calculate a certain residual. Ne? All right, so a residual, let me just make some space here. Allow me to make some space. Let me just shift this to the side. Okay, just gonna do some erasing of other stuff. Okay, like this one here, like this one, and this one. Okay, all right. Okay, so a residual. We are on the residual. Let me just use this to type. So no, it's fine. A residual a residual is equal to the actual y minus the estimated y. Estimated y. So in simple terms, a residual, definition of a residual, you can find it in the textbook and in the slides as well. Maybe it says it is the difference between the actual y and the predicted y. The difference between the actual y and the predicted y. So basically, you must take the actual y and you must subtract the predicted y. So let's just remember our formula that says y is equal to 2.827 plus 2.088, because you're going to need this shortly, right? Okay, so now let's say they want you to calculate a residual corresponding to week number 4, ne? A residual corresponding to week 4. So okay, first thing you want to look at is you're going to go to week 4 and then ask yourself, what is the x value for week 4? The x value for week 4 is 5, ne? And then the actual y is equal to 13. So now that's the first thing you're going to write. The actual y is equal to 13. And then you want to ask yourself, what is the estimated y? So this is what you're going to calculate. For week 4, the value of y is 13, the value of x is 5. So you're going to go to the calculator and predict that value of y by using this um, this equation over here. So you're going to say 2.827 plus 2.088 multiplied by 5. Multiplied by 5. Pardon me, I forgot to put x here. So it shows that you're going to multiply by 5, and then you're going to say equal, that is 13.267. So you're going to write this as it is, ne? 13 13.267, 13.267, which is approximately 14 sneakers if you're going to put it like this. So it's going to be approximately 14 sneakers, but for now let's leave it like this for the residuals, only for the residuals. Ne? You don't need to um, round this off, right? So now that you have this, then you can calculate your residuals. Your residual is going to be equal to uh 13 minus this, minus 13, which is the predicted 13.267, and the answer for this is going to be minus 0.267. So remember, a residual can be negative. If a residual you calculate and it's negative, then that should be the answer. Don't write it as positive. And if you see that this is a small number and this the predicted one is a bigger number, don't say this minus this to get a positive number. No, you must say the small number that you get as your y minus that number that you get as your predicted y, right? That is the a residual. So basically the difference between the two. And now, and now for the uh, residual, uh, now for the residual plot. So basically a residual plot is going to look something like this. It's going to look something like this, and then here you're going to have your x, and here you're going to have your residuals. Residuals. Let me just rotate this and put it like this. So a residual plot, I'm just going to make a rough sketch of this. You can find it in your slides. I don't think they'll ask you to do this, but if you feel like you want to know this uh, for certain, you can just hit me up. I'm going to leave my number in the description below, uh, so that you can just ask about this. But I hardly think they'll ask you to draw this. So basically, using this, you're going to have your x values, which is going to be, in this case, let's just write 1 up to 6, since that's what we have there. It's going to be 1, 2, 3, 4, 5, 6. Let me just put some spaces in between, or I'll go through it more in the next part. Okay, so let's just say this is your x values. Let me put them actually here on this line. These are your x values, and then now you want the residual. So residual that we have was minus 0.267. So if this is 1, let me just write 1 here. Let me just write 1 minus 1 here, minus 1, and positive 1 here. So this one here is going to be between what was the value of x? It was 5, so it's 5 and minus 0.267, somewhere there, somewhere here. So if let's say this is minus 5 minus 0.2 is going to be somewhere there, and your point is going to be there. So basically a residual plot is the graphical representation of the x values against the residuals. Is the x values and the residuals, not x and y, or x residuals and y residuals. No, we don't have x residuals actually. Residuals is actually based on y only. So a residual plot is going to look something like this. So you can do that the same, how to calculate the residuals for all the others, and then after that you take your x values and your residuals, plot the points here. So that is how you actually draw a residual plot. So the points are going to look something like this. They're not going to be like different or something like that. So it's going to be something like this. So now, how do you interpret this residual plot, or a graphical representation of the residuals? So now, if these points are closer to this line here, if the points are closer to this line over here, then you say the data is the least squares line fits the data, or there's a good distribution, like the distribution of the data is normal. There's a normal distribution of this data. Yeah, I think that's how they interpret it. There's a normal distribution of this data, because you can see that they're closer to this line of 0. There's a line of 0 here, which is this line, and if the points are closer here, then there's a normal distribution. And then from this, they can actually ask you about the outliers and influential points. So basically, you can see that all these points are somewhere between this minus 1 and positive 1 and minus 1. So you can find that one of the points is somewhere here. One of the points is somewhere here. So basically, that point is going to be an outlier, because all the points are within this interval. So there's one point that is somewhere there, which is for positive. Maybe let's say that's 2. It's 3, let's say 3, and residual for that is, let's say, 2 or 4. So that is going to be an outlier. And then sometimes they say an influential observation or influential value. So you can see that, let's say there's a scatter plot, I mean a residual plot that looks like this. All the points are here, somewhere here, and then you get one point that is somewhere there. So that point is going to look, is going to be an influential point or influential value. And then if a point is somewhere here, that is going to be an outlier. That's the difference between influential point and an outlier. And that sums up today's tutorial. And before you guys go and write the first test, I'm going to upload another video going through some previous question papers. So this was just a tutorial based on one information, but you can actually use this information to understand everything. That is part one. And in the next video, we're going to go through multiple regression, where we have more than one independent variable. I'm going to explain that in the next video, and I'll see you guys in the next video.